Welcome to the Math Record. Today we'll be learning about statistical probability. This video will cover part 4 of chapter 1 in our statistics class. Just a disclaimer, this video will be teaching statistical probability important for only this class. The more mathier based probability we will expect you to know, like how to read a chart. Anyways, let's begin. Let's start with the basics. This is usually done with Venn diagrams, but this could also be written as a table. So, let's have college and stats. So we have college, draw a circle, and then draw another circle that's overlapping it. This is called a Venn diagram, and we have stats on the other side. So and let's say the people that are taking just college is 4, and the people that are in college and taking stats is 2, and the people that are taking stats but are not in college is 3. And let's say there's 6 people outside that are not taking they're not in college or they're not taking stats. So this is the Venn diagram way to write it. The way you write it with the chart is that you kind of write it as like this. So you split into 4, and then you're gonna have like 2 variables. You have college and stats. Let's just write college as C and stats as S. So either you do have college or you don't have college. So I usually write it as yes or no, which I abbreviate as Y and N, and then Y and N for the other side also. So which one is taking college and taking stats, which is 2. Taking college but no stats, which is 4. And it's taking stats but no college is 3. And it's not taking college or stats, which is 6. And that's usually the table method. You might want to use the table method for more probability based when you want to read it in a different way. But usually the Venn diagram is a good method and it's fine enough for you to use. Okay. So the 2 things that we're gonna learn in this one would be independence and disjoint. Independence is basically the probability of one event does affect the probability of another. So this basically means, given our scenario right here with college and stats, would be does if you are taking college, does this improve your probability of taking stats? So that's basically what it means. Or if you're just a normal person and you're just taking stats, is there any effect? So basically, there's a really easy way to prove if it's independent. It's just using a mathematical rule. So the rule is the probability of event 1, one of the events, we'll just call subject 1, is equal to the probability that that event 1 occurs given that's out of event 2. So what this basically means is that uh, if it's out of the event 2's probability, what's the probability that this occurs? So if they're equal, then it's gonna be independent. Basically, so it basically states that if the probability of the college is equal to the probability of the college, given that's in stats, then then basically it's saying that college and stats are independent of each other. So if you take college, it doesn't mean that you have a higher chance of taking stats. That's basically what it means. So one does not affect the probability of another. So let's just put this into practice to see if it's true. So our thing would be probability of event 1. So the probability of college is equal to the probability of college given that they're taking stats, which is just basically you write it as a vertical line. So what's the probability of college, which is 4 plus 2, which is 6, because that's the total amount of college. And then out of the entire one, which is 4 plus 2 plus 3 plus 6, which is 6, 12, and 15. So we have out of 15. So the probability that you're taking college is 6 out of 15. Okay? So what's the probability that you are in college given that you're taking stats? If you're taking stats, there's only this amount, only this circle. So it's out of 5. So what's the probability that you're taking college? Well, out of the 5 people, only these 2 are in college because these 3 are just taking stats, not college. And that's what this overlap is. So that's 2. So when you simplify 6 out of 15, divide by 3 in the top and the bottom. So 6 divided by 3 is 2. 15 divided by 3 is 5. And 2/5 is equal to 2/5. So this basically tells us that college is independent of stats, basically. That's basically how you find it out. Another way to do this is basically similar, would be instead of looking for college and stats, we could use stats and then college. So what's the probability that you take stats? It's equal to the probability that you're taking stats, given that you're in college, which sounds more reasonable than saying it probability that you're in stats, given that your probability in probability in college equal to the probability that you're in college that you're taking, given that you're taking stats. Both of these methods should make equal, like they both should work out and they both should say they're independent. So let's just show it. Probability that you're taking stats, which is just 2 plus 3 is 5. Remember, it's the total. Amount of the total amount, which is 4 plus 2 plus 3 plus 6, which is 15, as I said before, is equal to the probability of that you're taking stats given that you're in college. So given that you're in college, that means you're only in college. So it's 4 plus 2 is 6. And you're only taking stats, which is just the middle part, which is taking stats in college. So it's 2. So out of the people that are taking college, which ones are taking stats, which is 2. So dividing this by 2 divided by 2 is 1. 6 divided by 2 is 3. 5 divided by 5 is 1. And 15 divided by 5 is 3. So 1/3 is equal to 1/3. So basically, this also tells us, this other way also tells us it's independent. So both of them both tells us that it's independent. If, let's say, this is not like 2 and this was like 3, then this would simplify to 1/2, right? And this is not equal to each other. So we then say it's not as independent. But since they are equal to each other, we're going to say it's independent. And that's a mathematical way to prove it. And we're going to be, and that's basically the general idea of like how to do it. Just use this mathematical idea, which is just the probability of, let's call it, if E is event 1, is equal to probability of event 1, so the same event, given that's in the other event 2. That's basically the rule. If you prove that those numbers are equal to each other, or like really, really close, like if it's like 0.15 and it's equal to like 0.14, you could kind of roughly say that they might be independent because it's so close together. Usually when these cases happen, there's going to be a lot of decimals and it's not going to simplify out really well. So it's just going to, you could argue that they might be independent because they're just so close to each other. But usually it's pretty explicit of what it is. If it's equal to each other, usually it's pretty independent. And if they're really close, they're pretty independent also. And the next thing we're going to talk about is disjoint. Disjoint would be like if both events cannot happen at the same time. So if you're taking like so in this example, which we take college and stats, right? This is not disjoint. This is not disjoint because this disjoint means in this case, in context, always put in context, would be that college is you cannot take college and stats at the same time, but you could. There's 2 people right here that are in college that are taking stats, so this is not disjoint. There's so something disjoint would be like if you're in college versus you're in high school. Let's call it HS, right? You can't be in college and high school at the same time, so that would be count as disjoint, you know? So this would be a disjoint scenario because the 2 circles are outside each other. If they're overlapping, then it's saying it's not disjoint. So that's basically what disjoint is. Disjoint is defined as both events cannot happen at the same time. At same time. So remind, college cannot it is not disjoint because college and stats can happen at the same time. So there's also a general idea that if something is disjoint, it cannot be independent, right? Because given our case, right, we said that this was independent, but then we said this is not disjoint. So if you follow this rule, generally you'll be correct. I'm not exactly sure if this always applies to every case, but it's a pretty good rule to know. But there's always like pretty easy ways to like identify it anyways. Using that rule that I told you for independence, you could always just tell if it's independent, the mathematical rule, and then you could just look at like the Venn diagram to see if it's disjoint. If there's anything overlapping, that's not disjoint. So if they're like separate circles, then it should be fine. Even if there's a number outside and there's like two separate circles, right? Then it's basically just gonna be disjoint. Well, that basically covers for the independence and the disjoint. Let's move on to the next one, which we're gonna be talking about mean and standard deviation of probability. So this one is usually written with as charts. So let's have something like this, right? So here, 1 and 2. Then we're gonna have something like the amount of money you win and like the probability, which I would just say is P. So let's say for it to win $10, you have a probability of 1/10, and to win $5, you have a probability of 2/10. But you have to pay. But let's say you lose $2, and that's the probability is 7/10. You know. So the first thing we have to do is we have to find the mean and the standard deviation. So the mean is basically just equal to the sum of parentheses of the amount times the probability. It's basically just that simple. So it's just 10 times 1/10 is 1, right? Sorry. 10 times 1/10 is 1. 5 times 2/10 is also 1, because 5 times 2 is 10, and 10 divided by 10 is 1. Negative 2 times 7 over 10th is negative 1.4. So this is 2 minus 1.4, which is 0.6. So your mean amount is $0.6 or 60 cents. It's basically just that simple. And now, standard deviation. Standard deviation, okay? You could just usually write this as SD. It's basically the same thing. It's how I write it as an abbreviation. To calculate this, you basically just have the square root of the sum, Euler summation, which is equal to sum of basically the value of the value, which is the basically amount, minus the mean. Sorry. And then square it times the probability, which I'll just write as P. Right? So it's basically just like this. So following that, I'll just show you the work. It's basically pretty simple always. So it's basically the square root. Actually, let's just write it as s first. S squared is equal to, because you have to square root it, so you just need to find s. So square root of the first number is 10, right? So it'll be 10 minus the mean, which is 0.6, as we said before. 0.6, and then you square it, because you want the standard deviation to be positive. But if it's not positive, some of the numbers might be negative, and then those negative and those positive might cancel out to make the standard deviation 0. So you want the standard deviation to be an actual number, because it's basically like that coin flip example that I talked about in our previous videos, where if you flip 2 heads instead of like a head and a tails, because you expect it to be equal probability, so it's a head and a tails, you don't want it to be like the standard deviation 0, because then you would say that the 2 heads is really unusual when it really isn't, because like because like getting 2 heads is not that unusual. So basically standard deviation 10 minus 0.6 squared, right? And then you multiply by the probability, which is 1/10. And then you add the next one, which is 5. 5 minus the mean again, 0.6, times the probability, which is 2/10, plus -2 is the next one, minus the mean again, 0.6. And then you multiply this one by 7/10. And then you basically add it all up together, right? And then you square root it. This thing, the one that's squared, s squared is equal to some number. The x squared is called the variance. So let me just write it out right here. Variance. So whenever you want to like add standard deviations, we're gonna explain this further on, that later on in the video. That you don't, if you add standard deviations like together, like one standard deviation plus another standard deviation, you cannot do that. It's not a thing. You have to add the variance and then you square root it. So basically, like let's have standard deviation 1 and standard deviation 2. So you have standard deviation 1 plus standard deviation 2 is equal to the last standard deviation. That is not true. You have to have standard deviation 1 that is raised to the power 2, and then you have to have the other standard deviation raised to the power 2, and then you add them together, and then you square root that number, and you get, because you have to add the variances, and then you square root it to get the that standard deviation, the new standard deviation. So that's why variance is important, that I'm going to introduce like right here. So basically, let's calculate the standard deviation. Multiplying these all together, you could use your calculator, but basically, it's going to be equal to the standard deviation would basically equal to like the square root of like 17.44, I think. Which is which you could write as like some decimal points. So let's say square root of 17.44, whatever the amount is. It's, yeah, I usually write into 3 decimal places. So based on this, I usually write it's approximately equal to 4.176. It's okay to write it as 4.18 if you just want to write it to the hundreds place. I usually use it to the thousands because I want to be as precise as possible. But it's fine either way. They're not going to deduct points because of like where you want to round it. Usually to the hundreds is fine. And that's basically how you find the mean and standard deviation. So the mean is equal to the sum of the amount times the probability. So multiply the amount times the probability and add those results together and you get the mean. The standard deviation is the square root of basically the sum of the amount of that amount minus the mean of each amount minus the mean, and then square it times that respective amount's probability. So that's basically how you find the standard deviation. Now let's start with the geometric model and the binomial model. The geometric model is geometric, right? Geometric is basically how long does it take for you to get your first success. But they have to be independent. For these models to work, they have to be independent of each other. So example would be like, let's say you're flipping a coin, right? Basically, the chances of you getting ahead, like the first time, is 1/2. The chance of you getting ahead the second time is also 1/2, and the third is 1/2. The fourth is 1/2. Like it doesn't change the probability. Just because you get a heads the first time doesn't mean you're guaranteed to get a heads the second time. You know, because the probability stays the same. So that's what it means to be independent. But let's say you have something like the probability that you get chosen in class, right? Let's say there's 30 people in your class, and the probability that you're gonna get chosen into like this group. So let's say what's the probability of you getting chosen the first time, which is 1/3, right? I mean 1 out of 30. So let's say you didn't get chosen that time. So what's the probability of you getting chosen the next time? It's 1/29 because one person is already chosen. So you see how that is not independent because like one probability affects the other. So that's what it means. For geometric models to work, they have to be independent of each other. So they have to be. Okay? So to calculate this is basically just the probability is equal to let's just call it prob because I don't want to confuse you. Probability is equal to the q raised to the power of n minus 1 times p, where 1 minus q is equal to p, and and where n is equal to the amount of trials, basically. So what does this mean? Well, P is the probability that you want to occur. Q is just basically 1 minus that. So if you 1 minus the P, you get the Q, basically. Because it's just P plus Q is equal to 1. Because they're just saying the probability of 1. So let's say the probability of you want to getting like heads, right? It's 50%. So what's the probability of getting you tails, which is just 1 minus the probability of you getting heads, which is just 1 minus 0.5, which is 0.5. So the probability of getting tails is 0.5. So that would be your Q. And basically the number of trials would be like, how many times does it take until you get like into so how long would it take for your first success to occur to get heads in like your third try? That's basically what geometric will be calculating. So let's say we're using the coin example, right? What's the probability that you get heads? You get your first. It's always something with first. First heads on the third, like trial. Following this formula, which it basically just what's the probability of Q? Q is just the probability because P is the one that you care about because P is what you want. So P is the heads, right? So times 0.5, that's the probability that you get it. Because and it's raised to nothing, so it's raised to the power 1, so you don't have to do anything. Q is just 1 minus the P, so it's 1 minus 0.5, which is 0.5. So in this context, it will basically mean the probability of getting tails. And the 3 is the number of trials because it's the third. So 3 minus 1 is 2. So the probability that you get your first heads in the third trial is 0.5 squared times 0.5, which is basically just 0.5 cubed, which I think is 0.125, which is like about 12%, 12.5%. So that would be the geometric model. So also for like when you're calculating for like any of these models, there's always a mean and a standard deviation. In stats, there's always basically a mean and a standard deviation. So a mean would be like what's the mean amount of uh basically like in this context, let's say the coin flip takes for you to get like a heads. So you have like 1 divided by p. It's basically just that simple. So let's say you have 1/2, right? So you have 1, and then the probability of getting heads is 1/2. It's 1/2. Let's write that as a fraction, right? So it's 1/2. It's 0.5. Is 1/2. Reciprocal 1 divided by 1/2 is basically 2. So you will get a heads in like 2 flips, which makes sense because like that's the mean amount. Because let's say you get tails the first time, then you're gonna get heads the second time, right? Or you could just get heads and stop there. So if it's a 50-50 chance, then it should be equal probability. And like theoretically, there should only be these are the 2 options, so it should be technically just 2. And that's what this geometric model is calculating. And now we have the standard deviation, which I'll write as SD, which is basically equal to the square root of Q divided by P squared. p squared, where p squared is in the denominator. So this is basically just how unusual it'd be. So in our case, we had like square root, right? We have 0.5 as q for the probability for tails, and we have 0.5 as the probability to get heads squared. So 0.5 divided by 0.5 would just be 1 all over 0.5 simplified. So that would just be 2. So it would just be square root 2. So this thing will be equal to square root 2, right? That's your standard deviation, which is roughly about like 1 point something. So which makes sense because you either have 1, you take 1, or you do not take 1 for the standard deviation. And it's basically that's from the mean. The standard deviation is like what's the distance away from the mean. So if our standard deviation is square root 2, right? Let's just say that's approximately 1. Then basically you have a mean of 2, right? And you have a standard deviation of 1. Then basically you're gonna have you have standard deviation of 1. 2 minus 1 is 1. 2 plus 1 is 3. So you add the standard deviation to the mean and the mean subtracted by the standard deviation. And you get these two numbers, right? This is standard deviation 1 on both sides. Then basically it's that it's not really that unusual if you get like 1 heads or like 3 heads. But maybe if you get something like 4 heads, it's kind of really unusual. I mean, it takes you 4 coin flips to get 1 head. Instead of taking 1 coin flip to get head, 2 coin flips or 3 coin flips. No. So this basically tells us how unusual it is, because this is the idea of statistics, to see how unusual the data is. Because is it really unusual that you'll get like that you get 4 coin flips to get a heads, which you could just use this as like a probability using means and standard deviation. There would be a way to calculate this, but for now we don't really need to know it. Okay. So this basically covers the geometric model. Just need to know your probability, and I don't know, I erased it, but the mean and the standard deviation. Next up, we have the binomial model. Binomial model. This basically answers like the amount of successes you could get. So let's say like you're flipping 5 coins, right? What's the probability that you get 2 heads, right? So uh this will work like the probability is calculated using combinations. So it will be the number n combinations of let's say x, actually let's say a, times q to the probability of n minus a times p to the probability of p to the power of a, where n is equal to the amount of trials and a is equal to the amount you want. So the number you want, basically. So using our coin example, let's say you flip 5 times, right? And you want 2 heads. So what's the probability of you getting 2 heads out of 5? So it'll basically 5 is the amount of trials because it's out of 5, and the number you want is 2 because you want 2 heads. So you have 5 combination 2, right? Because we said 5 was the amount of trials and 2 was the amount of the number we want, times q, which is the probability of not getting heads, which is 0.5, raised to the power of n, which is 5, minus 2, times the probability of you getting heads, which is p, because the p is what you want, the probability of getting heads. Q is the probability that p does not occur. So 1.5 to the probability of 2. So basically, using your calculator, you could just solve this out. So how you basically read this is basically just 5 factorial all over 5 minus that number. So in this case, it's 5 minus 2, which is 3 factorial. And then you write that number again, which is just 2 factorial. And then it's 5 factorial divided by 3 factorial and 2 factorial. So basically, factorial basically just means, like in this case, 5 factorial would just be 5 times 4 times 3 times 2 times 1, right? So if you have 6 factorial, it's just 6 times 5 times 4 times 3 times 2 times 1, right? It just multiplies all the numbers up until there, which is the natural numbers. So in this case, we have 5 factorial, which is 5 times 4, and then it's times 3 times 2 times 1, but 3 on the bottom is just 3 times 2 times 1, so those kind of cancel each other out, right? And then you just have that 2 factorial remaining over. So 5 times 4 divided by 2 is 10. So you have 10 right here times 0.5 to the power of 3 times 0.5 to the power of 2. So 0.5 to the power of 3 times 0.5 to the power of 2. Since there's the same base, we would just add the exponents. So 3 plus 2 is 5. Usually, sometimes you can't, because usually, since it's a coin and they have equal probability, you could do it. But usually, if you have something, let's say your probability that you want, that you get a, let's say like a marble, right? You have red, blue, and green. What's the probability that you get red, which is which is probability is 1/3 in fraction. You don't have to always write as decimal. And what's the probability that you get not red, which is just 2/3, which is Q. So right. So then you can't really add them together. This is 2/3, this is 1/3, and they're not equal. But coins are equal because the probability of getting tails and probability of getting heads is equal. So then you could just multiply this out, and that will give you the probability that you will get um, uh, 2 heads out of 5 trials. All right. Let's delete this. So just know this formula, and basically you'll get it. To get the mean for a binomial model, it's the mean is equal to n, which is the number of trials, times the probability that you want to occur. So n, in your case, with the 5 trials, and you want 2 to be heads. So what's the probability that you get heads, which is 1/2, right? So basically, the mean of getting out of 5 times, and you get a half of it is head, is 2.5. Even though for some reason, like, you can't get half of a heads, this is the actual theoretical probability. Because think about it, you get equal amount of heads and tails. So if you, let's say you you flip 6 times, then half of it will equal to 3, which makes sense because you get 3 heads and 3 tails because they have equal probability. Theoretically, though, because you could be possible to get like 4 heads and like 1 tails, or like 4 heads and 2 tails, because like it's not really like unusual, but it's something you could. Mean just tells us what's the theoretical like balanced amount, and that's why you have standard deviation to see like if it's really unusual. So the standard deviation for the binomial model is basically just the square root of n times p times q. It's basically just that simple. So it's n, the amount of trials, times p, the probability they want, times q, the probability that is not p. So that's basically how you calculate it. Um, so why you use the geometric model to solve questions for like and how long does it take to get your first success? The binomial model calculates for the number of successes, and you could also use the binomial model to calculate at least, or at most stuff. So let's say you have a case where you fit 5 coins, right? Sorry, you fit 5. You flip a coin 5 times, and you want to know what's the probability that you get at least like 2 heads, right? And then you're like and they also say like at most 4 heads. So at least, so it's 2 to 4 heads basically. So at least 2 and at most 4. So basically how you do this is basically using this general idea. You kind of just had to like know this formula. This formula is really important to know for binomials. But the general idea that I always use is basically you just use a summation, and then you have the bottom part that you want to get equal to is your least, which is 2. And then the top portion is the one that's at most, which is 4. So it goes from 2 to 4, which makes sense because A could equal 2, A could equal 3, A could equal 4. And that's basically what this stands for. And then they're basically like, plug in each A, like 2, 3, 4, into the equation, which you're just gonna write NCA times qn minus a times pa. And you basically do this. Usually when they have these questions, they'll probably give you a you probably could just use your calculator. So what you really do is that if you just plug the values in your calculator, this should give you the amount. Instead of like looking at because calculators also have a way called binomial models and geometric models. Um, like sometimes you might forget which one to use and which one's not. Just always use a summation. It's usually just correct. It's always just a summation. Just use a summation from like that amount. So if you want to if they say like in general at least two and they don't have to at most four heads, you just write 2 to 5. This is at least 2 out of 5 trials, so it's 2 to 5. Or like they say at most four, like it's just at most 4 heads, then you just have 1 to 4 because that's the smallest. At most 4 is 0 to 4 because you could also have 0 heads. You know, so it's basically if you just use a summation, you'll always get correct, and you always put it in the right form. Then you're fine. You don't plug in anything for a. So in our thing, you always plug in the n, you plug in the q, and you plug in this n over here, and you plug in this p. You can leave all the a's away from each other, and you basically just have those. So it'll be n combination a times q to the power of n minus a times p to the power of a, right? So you basically just plug this in, and you always get the right answer. And that's why I never like focus on if it's a geometric model or binomial model or like which type of binomial it is, because I could always just use summation. It'll basically get me the right answer. Or you could think about it logically. So that basically covers it. Also for like geometric models, if you do, if you want to know which one you need to use, it's basically really self-intuitive. So if they ever ask like anything is the first one that you thing that you want, then you gotta use a geometric model. But it's really easy to remember. As you probably only need to remember the mean and the standard deviation. For a probability, it's basically like what's the first time you get the fourth one, right? So the first red is let's say your first head is your fourth one, right? Which is so you only get one head because it's the fourth one because it's your first one, right? So the other one has to be all tails. And that's just basically it. That's basically just how you calculate it. It's really just that simple. So what's the probability that you get 3 heads in a row? I mean 3 tails in a row and you get 1 head? It's basically just like that. So the order kind of matters. So that's how you do geometric. Instead of like memorizing probability formula, it's basically just like that. And then for anything with binomials, it's the way that I teach you, which using summations. You can also do this with like basically tree diagrams also. So let's say what's the probability of you getting a heads, you know? So usually you kind of just write like this. So what's the probability of you getting heads? It's 1/2. And what's the probability of you getting tails is 1/2. And then what's the probability that you get 2 heads? So it's right here. So you have another heads, 1/2, and then one times 1/2 is 1/4. And then what's the probability that you get heads and then you get tails, which is just 1/2 times 1/2, which is 1/4. And then what's the probability that you get tails, which is 1/2, and then you get heads, so probably getting heads again is 1/2, so 1/2 times 1/2 is 1/4. And then getting tails and another tails is also 1/4, right? So they should always add up to 1. So this should always add up to 1. So 1/2 plus 1/2 is 1 is 1. 1/4 plus 1/4 plus 1/4 plus 1/4 is always uh basically 1. So even if you do another one, like another one, it's always gonna add up to like 1. Um, so when they ask like what's the probability that you get 2 heads, you get one. It's 1/4. What's the probability that you get 1 head and 1 tails? Well, there's heads tails this way, and then there's tails heads this way. So that's 1/2 adding together. 1/4 plus 1/4 is 1/2, and probably you get like 2 tails is 1/4. And that's basically what you do for tree diagrams. So let's use something else, like instead of using coins, because sometimes they're just equal and it's hard to understand. So let's say we have something like you want to get marbles, right? And you have like 1 red, 1 blue, and 1 green, you know? So what's the probability that you get red versus not red? So the probability that you get red is 1/3. Probability that you not get red is 2/3. And then you replace the marbles the second time and say, so if you get a red, you're gonna replace a red. So if you get red the first time, what's the probability that you get a blue? So the probability that you get not blue, a red again, which is just 1/3 times 1/3, 1/9. And what's the probability that you get red and then you get not red, which is 1/3 times 2/3, which is just 2/9. And not red. And what's the probability that you get non-red the first time and then red the second time, which is just 2/3 times 1/3, which is another 2/9. And what's the probability that you get two non-reds, which is just 2/3 times 2/3, which is 4/9. So it's 1/9 plus 2/9 plus 2/9 plus 4/9. That should equal to 1, which makes sense. Which 2/3 and 1/3 should also equal to 1, you know? So what's the probability that you get two reds? 1/9. What's the probability that you get one red and one non-red? It was just 2/9 plus 2/9, which is 4/9. And what's the probability that you get non-red, which is just 4/9? And that's basically how you use it for tree diagrams. You kind of just focus on the probabilities and you kind of just draw it out. Okay. And the last thing we're gonna be learning today is how to like scale means and standard deviation in general. So basically, let's say you have a set like 1, 2, 4, 5, 6, and 9. No. So let's find the mean for this, which is just 1 plus 2 plus 4, 1 plus 2 plus 4 plus 5 plus 6 plus 9. And then there's 6 numbers in there, so divide by 6. And the mean is 4.5, right? And the standard deviation is 2.88. Using your calculator. So what happens if you add like 2 to each of those numbers? So 1 plus 2 would make this 3, 2 to the 4, 4 to a 6, and then 5 to a 7, 6 to 8, and 9 to 11. Like, what happens if you add 2 to each of those numbers? Well, basically, the rule is that the mean will increase by that amount. So it increased by 2, so it becomes 6.5, but the standard deviation stays the same. Okay? Same. Okay? So the rule is that if you're adding or subtracting any numbers to basically this group, then basically the only thing that's gonna be affected is the mean, and it's gonna be affected by this amount. So you add 2 to each of them, then basically mean will increase by 2. And if you subtract a 2 from each of them, then basically the mean subtracts by 2. You have to do it for each of them. You have to do it for all of them. You can't add 2 to just like this 1 and they expect the mean to change by 2. It doesn't work that way. But if you add 2 to each of them, then the mean will increase, but the standard deviation would never increase. Basically, you're adding, subtracting. And that's the basic gist. And let's say what happens if you multiply each number by 2. So this becomes 1 times 2 is 2, 2 times 2 is 4, this is 8, this is 10, that's 12, and that's 18. So what happens to the mean? Well, the mean multiplies by 2. So 4.5 times 2 is 9. And 2.88 times 2 is 5.76. Right? So if you're ever multiplying or dividing, it affects both the mean and the standard deviation by that amount. So you divide by 2, you divide the mean by 2, and you divide the standard deviation by 2. And if you like multiply by 2, then you just multiply the mean and standard deviation by 2. And it's the same case. You have to multiply to every single number. You have to multiply 1, 2, 4, 5, 6, and 9 by 2. You can't just multiply like 1 by 2 and expect everything, the mean and standard deviation, to multiply by 2. It doesn't work that way. Okay? So now let's focus on like what happens if you add like some means together. So let's say you have one mean is equal to 4.5, and you have another mean that's equal to we call this mean 2 is equal to 3.5. So what happens if you add the means together? Well, it's really simple. It's just 4.5 plus 3.5. It's basically just that simple. It's just basically 8. So that will become the new mean. Or if you have like mean 2, mean 1, and then mean 2, and then you want to subtract mean 1 and mean 2, it's basically just going to be 4.5 minus 3.5 is 1. If you're adding and subtracting a mean together, you're basically just going to do the simple arithmetic. Usually in stats, you're just gonna be adding and subtracting means. There's no multiplying or dividing because it's not logically used. Okay, so when I said before in our earlier in the video that adding standard deviations is weird, well, I'm gonna be explaining this now. So when you're adding and subtracting like two different standard deviations, it's kind of you have to add the variances and then you square root it. So let's say your first standard deviation is 3 and your second standard deviation is 4, right? So you don't say the new standard deviation 1 plus standard deviation 2 is equal to like 7. It's not true. You can't just add 3 plus 4 and make 7. What you have to do is that you have to have the first standard deviation, sorry, squared, and then you have to have the second standard deviation squared, and then you square root it. So you have 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so square root 25 is equal to 5. So your new standard deviation is equal to 5. So this case applies for basically for the general idea of how to like add, subtract standard deviations. So you're adding, okay, my cursor. So if you're adding standard deviation 1 plus standard deviation 2, it's going to be equal 5 as I shown. And then if you're subtracting standard deviation 1 subtracted by standard deviation 2, it's also going to be equal 5. And if you have standard deviation 2 minus standard deviation 1, it's also equal to 5. They're all basically the same. They all follow the same formula. All these follow the formula you have to square both standard deviations and then add it to each other. Because you have to square the variances and add them together to get the new standard deviation. This would be called the variance, as I said before. Like it logically makes sense also. Like just because you subtract like some numbers from each other doesn't mean that the variances like are gone, right? Because let's say you have like a mean. Let's say you have like a group of numbers, right? Let's say some group of numbers, and you have a mean, and you have like some kind of standard deviation, you know? And then you have another group of numbers that are different, and you have a mean, and you have some kind of other standard deviation, right? Just because you subtract this first group by this second group, right, doesn't mean that this standard deviation subtracts away this standard deviation, and there's only two of the mean, and it's gotta be always this, you know, right? Because that doesn't make sense at all. Because there always is standard deviation. Just how unusual it would be. Because nothing is always like 100%. So when you're subtracting standard deviations from each other in any order, or you're adding them in any order, you basically just follow the rule where you basically just square the standard deviations, add them together, and you square root it. Even if you have a third standard deviation, it's just basically standard deviation squared plus standard deviation squared plus like the third standard deviation squared, and then you square root it. And that basically gets you your standard deviation. It's basically just that simple. Well, that basically covers statistical probability. So in summary, today we learned how to find the mean and standard deviation events in the rules along with along with the geometric and binomial model. Thanks for watching, and I'll see you at the next math record.